Today's session is about carbon compounds and carbohydrates, and in the early 1800s, chemists called compounds that were created by organisms organic because they had the same root word, and they found all these chemicals that they thought were only in living organisms, and for the most part they were. But they thought they were fundamentally different from those compounds that weren't in living organisms. Now we understand that the principles are the same, whether it's living or non-living compounds, but the term organic chemistry is still around. And so today, organic chemistry means is the study of compounds with carbon bonds. So organic compounds have carbon. And so all of the, most of the compounds that we're going to be looking at over the next week or two are going to be based around carbon. So let's look at carbon a little bit. I've got my little cartoon of carbon here, and he's got 4 arms. And the first principle, or the first characteristic of carbon that's really important, is that it has only 4 valence electrons. And that means that it needs 4 more to be filled. Well, the only way that it can get 4 is if somebody else shares with the carbon. And so they need to share their electrons, and this creates a covalent bond. So it has 4 covalent bonding spots. And so if we add up those electrons that come from the covalent bonds, we get 8 total electrons in its outer valence shell. And this is what we call the octet rule. And the octet rule states that, for the most part, atoms want to have a set of 8 electrons in its outermost energy shell. And it's with these electrons that elements are going to bond together with. The next thing that is really important to know about carbon is it has the characteristic of bonding really well with life elements. And what I mean by that is elements that are crucial to life. So the elements that carbon really bonds well with is itself, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And so these elements are extremely important in living things and making up the compounds that make those living things. And carbon does a really good job of sharing its electrons with those other elements. Now, since carbon can bond to other carbons, and that allows us to do some very special things that we can't do with other elements. So carbon bonds with carbon. And what that allows us to do is it allows us to create long chains. And make very complex molecules with their base being carbon. Also, carbon can form different numbers of bonds between 2 atoms. So carbon can bond in different ways. And what I mean by that is most of the time we will see carbon with a single covalent bond. But sometimes carbon will have a double covalent bond. And having a double covalent bond will change the shape of the molecule. On rare occasions, we can even form a triple covalent bond between carbon and other molecules. And again, getting that triple bond is going to change the shape of a molecule. So let's look at a couple of carbon compounds, the first one being methane. And methane is probably the simplest carbon compound that we have, or that we know of. And you can see that carbon has a single bond in between each of the hydrogens. But if we look at acetylene, acetylene has a double bond indicated by these two lines in between the carbons, a double bond between the carbons. If we put a couple of acetylenes together, we create butadiene. And so we see the double bonds that we saw in acetylene, but we also have this single bond in the middle of the structure. And you can see how the shape of this acetylene is a little bit different than what we see in this half of the butadiene. One of the other shapes that it can form is it can kind of bend some of these bonds together and create rings. And rings are going to be found a lot in life forms, especially in terms of sugars. Most of our sugars are going to be rings of carbon. And then I put isooctane in here because it shows the complexity of molecules just using, in this one, carbon and hydrogen, but this is a very complex molecule with several carbons branching off of one another. And so carbon is an element that can do a lot of different things, partially because of its size and how well it shares its electrons. And so carbon is going to create a lot of different molecules that can be put together and to make these great big macromolecules. And macromolecules just means giant molecules. And so the way we make these giant molecules is first we have something called monomers. And a monomer is a molecule. It is a small molecule, and this mono means one. So a monomer is going to be a small molecule that we can put together with other smaller molecules to create these giant macromolecules. So if I put a monomer together with another monomer, I'm going to get what we call a polymer. So I've got a picture of a polymer here, and I've got different colored blocks that are being put together, and each block is a monomer. It is a molecule that when we put it together with other blocks, we create this long chain, and as we put new blocks on, we go through a situation or a chemical reaction that we call polymerization. And usually polymerization is done through dehydration synthesis. So as we put these things together, and I'll show you this in a moment, as we put these things together, we are going to get water to come out of those molecules as they bond together. So if we put long chains of monomers together, we call that a polymer. So biochemists sort these macromolecules into four major groups. The first group are carbohydrates. Carbohydrates are sugars, and they're our main source of energy. Our second group are lipids. And there's several different types of lipids. There are lipids that compose butter, and other types of lipids are going to be in things like this avocado. But lipids are fats. Next we have proteins. And another word for protein is polypeptide. And we're going to find these in meats like chicken or eggs or fish or steak. And then our final major group of macromolecules in living things are going to be nucleic acids. And nucleic acids are going to be things like DNA, as we see in this picture, or a sister structure of that RNA. Alright, so those are our four major groups. Today we're talking about carbohydrates, and carbohydrates are compounds that are made up of carbon, hydrogen, and oxygen, and they're usually in the ratio of 1 to 2 to 1. carbohydrates are sugars, and they are our main source of energy. Sometimes some sugars can be used as a structural component. In other words, we're going to use them to build bigger objects. Structural components. They're going to be building blocks. And so a sugar we talk a lot about in biology is glucose. It's a very simple sugar. It is a monomer, and we call this a monosaccharide. Mono meaning one. We have one ring of glucose that comprises the whole sugar. Mono means one, saccharide means sugar. Well, if we count up the carbons, we have 6 carbons. If we count up the hydrogens, we have 12 hydrogens. And if we count up the oxygens, you're going to find that we have 6 oxygens. And if we divide all of those numbers by 6, we get a 1 to 2 to 1 ratio. So carbohydrates are going to be our main source of energy. They're going to be structural components, especially in plants. And glucose is one type of monomer, one type of monosaccharide. So here are a picture of 3 monosaccharides, fructose, glucose, and galactose. And if you count up the carbons, each part of the ring here that doesn't have an O next to it is a carbon. So if you were to count up the carbons, the hydrogens, and the oxygens, all of these things would have a chemical formula of C6H12O6, but they all differ a little bit in their structure. These are all monosaccharides. They are all monomers, and we can use them to build larger molecules. So for instance, if we want to build table sugar uses fructose and glucose, and they are bonded together. And here is where we have polymerization. This right here, we're going to take out a water molecule in our dehydration synthesis. And so this OH and this H will become water. A bond will form between this carbon and this oxygen. And that building of that bond is called polymerization through dehydration synthesis. And here we can see the glucose bonded together with the oxygen from fructose, and it links the two together. And that is called a disaccharide because di means 2, saccharide means sugar. We have 2 sugars making 1. But we can also build really long chains of sugars, and these would be our large complex sugars or macromolecules called polysaccharides. Remember that saccharides means sugar, poly means many. And so what we've done here to build starch, which is a polysaccharide, is we've put several glucose molecules and linked them together. Starch is usually found in plants, and that's how plants store their energy. Stored energy. Plants will also use another type of polysaccharide called cellulose. And plants will use cellulose to build cell walls. Animals use a different polysaccharide to store their energy called glycogen. Glycogen is animal stored energy. So all of these molecules are based off the element of carbon. In carbohydrates, we have carbon, hydrogen, and oxygen. And we can build small molecules called monomers, and in carbohydrates, those are called monosaccharides. And we can put them together to make our polymers, which are polysaccharides. We'll see everybody in class. Have a good night.